Welcome back. In this video I want to talk about the string library, so-called, which I get access to by getting all the includes, getting all the declarations from it by typing #include string.h. As I demonstrated in the last video, you can see what's in there if you forget by going man string, and you get a list of them there. They're also in the appendix of King, for example, or in lots of other places. The CPP reference would be another place to look for them. Let's look at a simple example straight off. I'm going to declare a new string, char star s. This is a literal string. It's going to be this is a string, and I'm going to want to print out how long it is. The way I'm going to do that is by calling a function strillen, which is declared over there. You'll see it in here. If I wanted more details about it, I could go man strillen, which says it calculates the length of a string. Calculates, notice. That implies some computational cost. Let's look first of all at how it behaves. I'm going to printf to say s is so many bytes %d characters long. And I'm going to call strillen on s. And you might think, well, that's got to work, right? Well, let's just see. Compile, no, it didn't work. Format %d expects an argument of type int, but argument 2 has type size type, aka long unsigned int. So %d is a 32-bit unsigned integer. This thing on our lab machines at least, and on the machine I'm running here, is potentially a 64-bit integer because strings can be rather long, in which case it wouldn't fit. So this is where I use the %z. I'm going to run with zu and the zd in this case, and compile and run it. S is 16 characters in length. So far so good. What strillen does is that piece of code there, which you may want to pause the video, maybe even want to type it in. This is a piece of code that runs through the entire string looking for the first occurrence of 0. So it's big O N in cost. Not a constant cost, just how long is it. Has to go find that 0 byte in order to say how long it is. This can have big bad ramifications if you write lousy code. There is a whole heap of other library functions. Only the blue ones are of interest to me in this course. You can look for the documentation on all the others, if you like, by typing man. Stritcher finds the first occurrence in a string of a particular character C. Stricomp compares two strings. I'd like to focus on that one first. Let's have another string here called s2, char star s2, which I'll write in a slightly different way. I'll write this one as, sorry, not a char star, as a char array, which we saw last video could be written in exactly the same way. So if I want to compare those, then you might think the code I would write would be if s equals s2, put s same. There's a very lousy, I'm in lecture mode, I'm going to type as little as I can. There's a, without the curly braces, I'm not sure if I should do that, but I just did. It doesn't print anything. They're not the same. How can they not be the same? We just saw they're the same. Hopefully, you may want to pause the video and turn your brain on. Hopefully you see why this didn't work. This is a pointer. This is another pointer. Are the two pointers equal? No, of course they're not. They're different arrays in memory. How could they be the same? So you can't do that. And the thing is to use stricomp. There's a catch with stricomp. If you've come from MATLAB anyway, stricomp compares two strings and returns an integer value. What is that integer value? Well, it's either negative, 0, or positive. Notice I did not say -1, I started to. Negative, 0, or positive. Some implementations it's -1, 0, or +1, and I've had students have difficulty moving code around assuming -1. Don't do that. Negative, 0, or positive for less than, equal, or greater than. This is different, by the way, if you've done MATLAB and you've met the stricomp function in MATLAB. It returns true or false depending on whether they're equal or not. Different, same name, different behavior. So now with stricomp, I hope when I run it, I get told, oh, I didn't, that they're the same. Oh, because I haven't done the check properly yet. Stricomp equals 0. I just fell into my own trap that I was telling you about. If the strcomp returns equal, they're the same. 0, they're the same. Bit of a catch. That's strcomp. Str looks for a particular character in a string. More generally, there's another function looking on here, str, which looks for a particular string in another string. This is generally a little bit more useful to you. Both the functions return a char star. This is worth commenting on. If I have a string s here and I'm looking for is inside it, let's do that. I'm going to printf, and what's the type of the value it returns? Well, it's char star, so I better print a pointer, which, as you can guess, isn't terribly useful. The str inside the string s of the string is. Oops, double quotes. That will tell me where is lies within the string. This is a string. I don't need s2 anymore. I do that and I get a totally useless answer. That's where it is, whoopee-doo. If I don't find it, it will return an error value. Let me just see what the error value is by running that, and it prints nil. It prints the actual null. I get a null value back. So it didn't match. So it can be used in that form to check if it's found or not. Otherwise, however, if I want to find where it was in the string, I've got to do some arithmetic. So I'm going to subtract s from it, and now I can print it as a decimal number, ZD, and the answer I get is 2. So I find is at index 2, 0, 1, 2. Right? Tricky arithmetic needed to get there. That's str. You can do the same things with the previous one I had there, which is str, which looks for a single character in a string. Strillen we've done. That leaves one important issue, string copy, which copies one string into a destination location. Let's look at destination locations. Let's declare a char array buffer, which I will allocate 100 bytes to, and I will initialize it to 0. I can now copy, using string copy, from S into, to the buffer, from S, better get them around the right way, A. Notice one of them is const, the other isn't, so the target is the non-const, because we're going to modify it. And I have to pass into this function a size. How big should I, or what should I pass in for size? I'm going to pass in the value 100 because that's the maximum size you're allowed to copy. When I've done that, I'm going to just print the string, or put s, the string at location buffer. Compiles, runs, prints, this is a string, no great surprise. I use string copy. I did not use the function crossed out strcopy, which is much easier. I don't have to give it a size. The problem with not giving it a size is that string copy will just keep copying as much as it needs to. Let's suppose we have a 5-byte buffer and I run that code now. I'm going to copy, if I just use string copy, I'm changing my mode, I'm doing the illegal one. I'm copying this is a string into the 5-char buffer here. As you can probably see, it isn't going to fit. What's going to happen? Stack smashing detected again, our old friend. So I'm banning copy and requiring you to use string copy. What I do not want to see is the mindlessly stupid, I shouldn't say that because a lot of people do it, but I'm sorry, people who do this are not understanding, strillen of s. I'm going to copy into buffer the entire string s, giving it a maximum length of whatever the string is. That is just so wrong, because however big that is exactly what strcopy was going to do before, and all I get is the same stack smashing detected, except I had to do, we get some ugly things happening. First of all, stack smashing detected when the function returns. So this is worse than useless, because the version of string copy like so will achieve exactly the same thing, but it will be at least twice as fast before it crashes, because this version has to traverse the list first to find how big it is before copying all those bytes into a place where there's not enough room for them. So don't use strcpy, please. In fact, the man page, you may want to go man strcpy and see what it says about it. So that's what that one says. Don't do that, please. There's also a slide here on strlen, and there's a couple of different versions of it you may want to look through just to reinforce your ideas of how string works. And I strongly encourage you to write your own versions of a few other string library functions. I don't guarantee anything, but I normally ask at least one, write the following string library function yourself in the test, just to make sure you're familiar with what's going on in string functions. That's enough for this video. Thanks for watching. Bye.